day, my friends. Our topic ngayon would be ESAT9. This will cover data communications. I am Engineer Andy Aliado from Morph Cebu. So these are our subtopics ngayon. We have to discuss data flow. Then we'll be talking about network and line configurations, the topologies, OSI model, network connecting devices. We'll be dealing with error controls, then the internet, and lastly, the internet protocols. Okay, so let's define what is data communications. Data communications are the exchange of data between two devices via some forms of transmission medium such as wire or cable. So it's merely just a communication between two devices. Kaso nga lang, this is digital na, no? Because data na yung pinag-exchange natin. So it's not just an information. It is an information that has been processed, organized, and etc. No? So yun na yung pinag-exchange dito in a napakalawak na network. So ito na yung kabuuan ng ating data communications. So it could be from your cell phone. Pwede sa cellphone mo papuntang internet. No? So pwede rin laptop papuntang internet. Pwede rin one computer to another computer papuntang internet, or di kaya from your cell phone to the cell site papuntang internet, no? Passing through your internet service provider. So yung internet service provider, sila yung nagbibigay ng serbisyo, no? Na ma-access natin yung internet. So kung paano nagfo-flow yung data natin dito, and ano yung mga rules and regulations or what we term as protocols na fina-follow nila, and ano yung mga kaukulang mga devices na ginagamit along the way. So yun yung pag-uusapan natin sa topic ngayon, no? Data communications. So let's begin with the data flow, no? So we only have three basic data flow talaga, no? So pinakauna is yung simplex. Pag sinasabi mo simplex, it's one way lang, no? So halimbawa keyboard to your computer, like CPU. So isang direction lang yan. So because your keyboard is just an input device, so that is one way. Or di kaya from your computer towards the monitor, that is only one way lang din, simplex lang din yan. So because your monitor is an output device lang, so that is what you call simplex. So if it is only one direction, hindi pwedeng mag-reply kumbaga, then that would be the simplex. So kung dalawang direction na, like si computer A nag-transmit kay computer B, tapos si computer B pwede rin mag-transmit kay computer A, and computer A is receiving it, then that could be half duplex, provided na hindi sabay. So dapat pag half duplex, hindi magkasabay. Kung halimbawa nagta-transmit ka, hindi ka pwedeng mag-receive. Kung halimbawa nagre-receive ka na, hindi ka pwedeng mag-transmit. So kumbaga it is transmission and reception but not simultaneous. At a time lang siya, no? Kasi nga pag simultaneous na, yun na yung full duplex or what we term as the duplex. So kung duplex lang, ibig sabihin nun full duplex yun. So in a full duplex or duplex, it means that you can transmit and also you can receive at the same time. So pwede magkasabay, transmission and reception, pwede magkasabay sa full duplex na uri ng data flow. So yun lang, napakadali lang, no? Simplex, half duplex, and full duplex or what we term as the duplex. So now let's move on to the network. Ano ba yung network na pinag-usapan sa datacoms? So as long as may connection ng dalawang terminals or dalawang nodes, network na yung tawag natin dyan, no? Minimum dalawa. So it is a set of devices connected by communication links. No? So kung meron kang dalawa, that's a network. Meron kang tatlo, network na rin yan. No? So ano ba yung ibig sabihin ng node? Ano ba yung ibig sabihin ng link? So pag sinasabi mong node, yun yung actual na device, no? Like a printer, like a computer. So as long as kaya niyang mag-process ng data, no? Input-output device, then that could be considered as a node, such as your cell phone, your computer. So yun, no? Tinatawag nating node, no? Tapos there is a link between those nodes, no? So yun yung tinatawag naman nating links, no? The link is the physical connection natin, no? So the communication pathway that transfers data from one device to another is considered to be a link, no? So just like this one, no? We have a path for your data dito sa computer A papuntang computer B. So this could be considered as a link. Now, itong mga arrangement ng links natin is meron tinatawag na line configuration, no? So line configuration is nababase dito kung paano pinaghahatian or ginagamit yung links sa isang network. So there are actually two lang, no? So we have point to point and we have also multipoint. So pag sinabi mong point to point, it means na meron ka lang isang link, tapos dalawa lang talaga yung nakakonect nun. So ibig sabihin dedicated, no? So dedicated, walang ibang pwede makapag-access nun kundi yung dalawang terminals lang ng link mo. in which that is kaibahan naman dun sa tinatawag nating multipoint, because sa multipoint, halimbawa dito sa pangalawang figure, there is still also one link. So isa pa rin yung link natin, kaso nga lang pinaghatian siya, no? So kumbaga they are sharing one link, no? This is a network of nodes or terminals in which they are sharing one link. So yun na yung tinatawag ng multipoint, or what we also call multi-drop. So one which more than two specific devices share a single link. So yan na yung tinatawag ng multipoint, different talaga sa point to point. So ngayon na alam na natin yung mga line configuration, let's talk about this difference ng mga laki ng ating mga networks, no? So these are the three basic categories ng mga networks natin, no? So we have the LAN. So yung LAN, pinakamaliit yun na network na pinag-usapan natin ng mga connections ng mga computers or mga terminals. So it is usually privately owned and links devices in maliit lang, like isang opisina, isang building, or isang paaralan, no? So it is within a certain boundary lang talaga na maliit, no? Tapos dati yung pinakaunang LAN is wired, but obviously ngayon meron ng mga tinatawag na wireless LAN, no? So sikat na yung mga wireless LAN. So wireless LANs are the newest evolution of the LAN technology, no? So yun na yung wireless LAN na tinatawag natin. So yung wired LAN actually is following the standards of 802.3, and the wireless LAN follows the standards naman of 802.11. So yun na yung mga IEEE 802.3 or IEEE 802.11. So ito yung sa wired, ito na yung sa wireless LAN. Now, LAN is maliit lang, no? So hindi natin ma-consider na pag nakakonect ka sa internet, LAN ka, kasi nga pag internet malawak na yun, no? So as long as kumbaga meron kang network na hindi naman connected sa internet, so that could probably be a LAN if nandun lang yan sa isang bahay, isang building, isang campus, no? So a very good example is pag halimbawa meron kang 5 computer na pwedeng makapag access sa bawat isang computer din, no? Or di kaya connected sila sa isang printer, no? So that could be a network and that could be considered as a LAN. Pero pag halimbawa, ayan, no, simple as to computers or as computers na marami ng mga nakakonect, no, like audio and video peripherals, no? Pero kung halimbawa nakakonect ka na sa internet, yun na yung tinatawag nating wide area network, malawakan na, no? It provides long distance transmission of data, image, audio, video over large geographic areas. It could be one country, one continent, or even the whole world, no, na tinatawag nating World Wide Web. So pinaka-example ng one is yung pag-access natin sa internet, no? Example niyan is yung dial-up dati, no? So ngayon parang wala nang nagda-dial-up, no? It's more on the DSL na talaga, fiber and broadband. So yun na yung mga ginagamit to access the internet. So internet is considered as a wide area network talaga, no? Because it covers pinakamalaki na worldwide na yun, no? So, in between the WAN and the LAN, yun naman yung tinatawag nating MAN or Metropolitan Area Network. So, a Metropolitan Area Network is mas maliit kumpara sa WAN, but mas malaki naman kumpara sa LAN, no? So, it could cover a city or a town. So, pinaka-common nito is yung example nito is yung mga cable provider dati sa TV, no? Yung mga community antenna television na ngayon naging carrier na rin sila ng let's say network din, no? So like cable internet, no? So that could be considered as a metropolitan area network, no? So yun yung kaibahan ng tatlo, no? We have the LAN, the WAN, and the MAN. So ngayon pag-uusapan natin kung paano i-connect yung mga terminals natin, whether logically or physically, no? So yun na yung tinatawag nating topology. So topology is arrangement lang naman talaga to, no? This refers to the way in which a network is laid out physically. It could also be logically, no? So this is geometric representation ng relationship ng mga links. So kung paano in-arrange, kumbaga, no? So and we have 4 basic na topology. We have the mesh, we have the star, we have the bus, and we have the ring. So let's begin with the mesh topology. Now, pag sinabi mo mesh topology, this is redundantly using kable, no? Mga kable, no? So every device has a dedicated point-to-point link to every other device. So just like this example here, no? Bawat isang device, si A, si B, si C, at saka si D, are connected to any other device redundantly, no? So si A nga, tatlo yung connections niya, oh. Si C, tatlo din yung connections niya, si D, ganun din. So ibig sabihin, this could be napakaganda because maiibsan yung traffic dito, no? So dedicated line, point to point bawat terminal, no? So A to C, point to point, A to B, point to point, A to D, point to point. So the advantage talaga ng mesh is that walang masyadong traffic. So hindi ka na mata-traffic kasi dedicated, eh. Oh. So at the same time, secured na secured yung data mo kasi nga walang nakakipag-share sa link mo. Oh. So it's point to any device. So the disadvantage lang talaga ng mesh is that it requires a lot of cables. So magastos siya, expensive siya, no? So at the same time, na madami nakakonek na kable sa terminal mo. So what if 100 terminals yan i-interconnect natin? So that could be napaka-bulky na cabling doon sa part mo. And sa part ng any other nodes dito sa mesh na topology. So halimbawa, meron tayong apat lang na device na in-interconnect. Ilan na yung kable na ginamit natin? 1, 2, 3, 4, 5, 6, 6 na, di ba? Pero what if 100 yan? Ilan yung kable na gagamitin? Actually, pwede naman natin masolve. So ito na yung formula para masolve natin yung dami ng wires to be used to interconnect mesh topology. So halimbawa dito, we have 4. Yung n natin is number of nodes. So we have 4. Tapos n minus 1. 4 minus 1 is 3. So that is divided by 2. So that gives us 6. Ang tama, no? So we have 6 wires na ginamit dito. So that is the mesh topology. And this is very robust na type of topology. Pag sinabing robust, ibig sabihin nun, hindi siya madaling ma-disable. So for example, si letter D na terminal na nasira, no? Hindi na siya part ng network. So si A, B, and C could still communicate with each other. So that's the beauty of mesh. So merong advantage, meron ding mga disadvantage. Now let's move on to the star. So si star topology, isa yan sa pinakasikat ngayon, no? So each device has a dedicated point-to-point but not to other device but to the central controller. So yun yung pinaka-characteristic ng star topology. Naka-connect ka point-to-point pero hindi sa ibang devices but a central controller just like this one, no? So this is an example of a star. So lahat kayo naka-connect sa central connectivity device. So halimbawa si A mag-transmit kay B. So trabaho ni central connectivity device na i-forward yung data mo papunta kay B, no? So that would be the job of the central connectivity device, and that could somehow reduce the number of wires, no? So kanina 4 kayo in-interconnect ng mesh, 6 na kable. Ngayon 4 kayo, meron tayong star topology, 4 lang din na kable. So if you will be having 100 na terminals, pwede rin 100 na kable, no? So if your central connectivity device is capable of handling 100 terminals at a time. So that would be somehow advantageous compared sa mesh topology. So pinaka-problema lang ng star is if masira yung central connectivity device. So in terms of terminals lang yung masira, robust pa rin ito, no? So hindi pa rin ito madaling ma-disable, like masira yung terminal na yan. So the rest of the other network terminals could still communicate. So pinaka-disadvantage lang nito is if itong central connectivity device yung masira. So if masira yan, disable talaga yung network. So yun yung problema din ng star topology, no? So may mga advantage, meron namang disadvantage. So kitang-kita natin dito na pinakakaiba talaga ng star and mesh is that si star hindi talaga nakakonect yung mga individual devices nyo physically, no? So it's all terminated into a central connectivity device or central controller. So ito na yung setup ng normal na mga internet cafe, no? So normally sa mga internet cafe naka-star yan. So they may use hubs or they may use switches together with the router para makakonect tayo sa internet. So that is an example of star topology. So actually sa star pwede ka naman gumamit talaga ng hub, pwede switch, no? Pwede router. So as long as it could act as a central connector and could distribute the data or forward the data, so that could still be used as a central connector dun sa ating star topology. So another topology is the bus, isa sa pinakaunang ginamit ng LAN, no? So yung mga 10 base 2, 10 base 5 na LAN, so they're actually using bus, no? So it's a multi-point, no? So kanina si mesh is point to point, si star is point to point. So ngayon si bus, it's a multi-point. So it's a multi-point connection of nodes in one long cable that acts as a backbone to link all other devices. So pag nag-layout ka ng bus, halimbawa ito yung floor plan ng building mo, tapos nandito yung mga rooms ng opisina mo. So pag nag-layout ka ng bus, madali na lang, easier yung connection kasi nga i-layout mo lang yung bus dito. Ito na yung bus mo. Ayan. Tapos kung meron kang mga computer sa mga room, i-tap na lang yan sa inyong bus. So kaya nga napaka-easy yung installation ng bus. Madaling mag-install yung ng bus. And obviously, mas tipid siya ng kable. No? Isa lang yung kable na mainline mo, tapos mga drop lines na lang yung papunta dun sa mga nodes or mga terminals mo. No? So this is an example of a bus topology, and yan yung tinatawag nating bus, no? Yung mainline natin. Tapos in the bus topology, we'll be using taps at saka drop lines. Ito na yung tinatawag nating drop lines and taps. So ito yung drop lines, yung sinabi ko, yung ito, mga drop lines. And ito mga part dito kung saan ka nag-connect, yun na yung tinatawag nating mga taps. So that is yung bus topology. So advantage ng bus, madaling mag-install. Hindi rin naapektuhan yung network mo pag may masirang isang terminal. So wala ding problema. So yung problema lang ng bus is medyo matraffic yung data dito kasi nga you are using only one highway. At the same time, it is very prone to collision of data. So magbabanggaan yung data and that could lead to unerroneous na data. So yun yung mga problema ng bus topology. So the advantage, simple, no? Madaling mag-connect o madaling mag-install ng mga terminals. No? So another topology is yung ring topology, no? Yung tuloy-tuloy na connection, no? So para siyang bus pero in a form of ring, but it's actually different from the principle of bus. So each device has a dedicated point-to-point na naman with only two other devices on the side. So ibig sabihin from here to here, point-to-point siya. From here to here, point-to-point din siya. So ano yung ibig sabihin niyan? So ibig sabihin pala nito, everybody will take part on the in the relay of data. So kung halimbawa si A magta-transmit kay C, hindi niya pwede i-transmit kaagad yun kay C because kailangan dadaan muna yun kay B. So yun yung ring topology, no? So ipapasa niya dito kay B, parang relay, no? Relay yung sa track and field na relay, no? Tapos si B ipapasa niya kay C. So that would be the flow of data in the ring topology, which becomes a disadvantage na ngayon because nga what if nasira yung B? So if nasira yung B, hindi na makapag-proceed si A papuntang C kasi dito disconnected na yung ring natin. So yun yung problema, no? So at the same time, kung masira din yung ring natin, like maputol yung ring, hindi na rin makapag-connect ng data dito sa ating ring topology, no? So each device in a ring, para makapag-circulate yung data kahit mahaba yung ring mo, should incorporate a repeater. So we will talk about a repeater mamaya-maya, no? So itong repeater na to, ito yung nagbibigay sigla sa ating mga decaying na mga signals para makapag-proceed pa sa transmission ng ring kahit yung next terminal mo is medyo malayo-layo pa, no? So in just for the cases na maputol yung ring or ma-break yung ring, so there is another way para ma-preserve pa rin yung network natin, and that is to use dual ring na concept, no? So the dual ring is meron tayong backup na ring, no? Just in case maputol or masira or magkaroon ng discontinuity yung ring natin. So yun yung apat na topologies natin, no? So we have the mesh, we have the star, the bus, and the ring topology with their advantages and disadvantages. So now let's move on to the OSI model.